Welcome to myprojectbazaar.com. Our product title is a new cascaded switched capacitor multi-level inverter based on improved series parallel conversion with less number of components. Next, we see about abstract of our product. Multi-level inverter has gained popularity in various fields like photovoltaic systems, HVDC systems, fax devices, industrial drives, etc. It has numerous advantages like lower harmonics, low switching losses, low stress on switches, etc. There are different topologies available like neutral point or diode clamped inverter, flying capacitor inverter, etc. Each having its own advantages and disadvantages. The efficiency of this inverter is greatly improved by reducing the number of switches of inverter. The proposed work takes into account a cascaded topology to reduce the number of switches. To find the effectiveness of the cascaded topology is improvement of efficiency. A simulative study is done to evaluate the effect of topology with increasing voltage levels. In this proposed work, the multi-level inverter topology with reduced number of power switches is presented, and it can generate both even and odd level. The proposed topology is suitable for symmetric structure. This symmetric structure results in reduction of power switches, power diodes, and gate driver circuits, and also it may further minimize the installation area and cost. To prove the proposed topology is compared with conventional topologies performance. Thus, performance of symmetric multi-level inverter has been tested by computer-based simulation setup is developed and results are verified. These simulations are done in MATLAB. Next, we see about the flow diagram. In this proposed work, we achieve the drawbacks of existing system and compare to the result with existing method. The proposed circuit is named as basic unit and contains two DC power supply, two capacitors, two passive power diodes, four active power switches, and six MOSFET switches. Input source may be a photovoltaic cells, batteries, and fuel cells can be used as a power supply in this structure. Switches SA and SB are used in series parallel conversion respectively. This is the flow diagram of our product. This is the input source. This source is a DC supply. The source may be a battery, PV cell, or fuel cells, and the DC supply is fed to the inverter section, and this inverter components are connected in CSMLI topology. That means cascaded switched capacitor multi-level inverter topology, and the inverter switches such as MOSFET IGBT are gated from the gate driving circuit, and the technique is space vector PWM technique. Using space vector PWM technique, the pulses is generated and it fed to the inverter switches through the gate driver circuits, and space vector PWM technique is more efficient compared to the other PWM techniques. After conversion of DC to AC, that AC supply is fed to the load. Here we using RLC load in this our product. Next, we see about running process of our product. Computer simulation is carried out as the first step to examine the performance of the proposed multi-level inverter. For this purpose, a simulation module of the 5-level inverter is developed in MATLAB Simulink environment. In this proposed circuit consists two DC sources, each have 400 volt DC supply. Two diodes, namely D1, D2, are connected in source leg. Next, two capacitors are connected in between the series parallel switches that namely C1 and C2. That range is 10 microfarad and totally 10 power electronic switches is used here. MOSFET is used. Finally, the staircase output is obtained in the range of around 1100 volt. The output level is boosted due to the presence of capacitors. Next, some advantages of multi-level inverter. The multi-level inverter produces common mode voltage. Due to this, reducing the stress of the motor and don't damage the motor. Input current. Multi-level inverters can draw input current with low distortion. The multi-level inverter can operate at both switching frequencies, that are higher switching frequency and lower switching frequency. It should be noted that the lower switching frequency means low switching losses and high efficiency is achieved. Last one, reduced harmonic distortion. Selective harmonic elimination technique along with the multi-level topology results the total harmonic distortions become low in the output waveform without using any filtering circuits. In our product, the connections are given as per the circuit and the output is getting from the corresponding scopes. Next, see the corresponding outputs. First one is the corresponding gating pulses of our product, and next one is the space vector BWM technique control signal waveform. Next one is the input source. Already I told that the input source is DC source and each DC source having 400 volt. This is the input waveform for our product. And next one, the output waveform of our product. The output waveform is obtained in the staircase form, and this are only 1100 volt in the AC supply, and this AC supply is fed to the corresponding load. Here we using RLC load. And next one is total harmonic distortion waveform in our product. The window is a total harmonic display window, and here the value is presented, and that value is 31.03 percentage. This value is also very less compared to the other conventional method.